In this video, I will explain what Bitcoin compressed and uncompressed addresses are. Before I go into detail what compressed and uncompressed addresses are, first I will show you an overview how these keys and addresses are related to each other. First, we start with a randomly generated private key, which is usually 32 bytes long. Private key is used to generate the public key, and the public key consists of an X value and a Y value. If you do not understand why the public key consists of an X and a Y value, please watch part 11 of the blockchain tutorial series. The X value is 32 bytes long, and the Y value is also 32 bytes long. Inside the blockchain client, and the client is a software application, the public key can be represented in two ways: in a compressed way or an uncompressed way. If it is represented in a compressed way, it is 33 bytes long. If the public key is represented in an uncompressed way, it is 65 bytes long. I'm using the word key in private key, public key, the word key, and also the public key compressed, the word key, and uncompressed public key, the word key over here. Each time if we use the word key, these are numbers which is used inside the application, inside the software program. These keys are numbers which you usually don't see and use. Here the word addresses is used: compressed public address, uncompressed public address, with compressed private address, and with uncompressed private address. Public addresses are created to make them easier to handle by humans. For example, implement checksum digits to detect address mistypes. For more reasons why addresses are created, check out part 15 of the blockchain tutorial series. This public key representation is used inside a Bitcoin application. This public key representation must be converted in such a way that it can be used by humans. And that's the compressed public address. The same applies to this uncompressed public key. It must be converted in such a way that it can be used by humans, and then it will become an uncompressed public address. This private key must also be converted in such a way that it can be used by humans. This private key can be converted in two ways. You have the compressed private address, or you have the uncompressed private address. But the important thing is to know a private key has a compressed and an uncompressed form. A public key has a compressed public key form and a corresponding compressed public address form. The public key can also have an uncompressed public key form and a corresponding uncompressed public address form. In the next slide, I will show you an example of a private key, public key X coordinate, and a public key Y coordinate. By now, you should know that a randomly generated number is the private key, and this key is used to calculate the public key, which is a pair of integers, which consists of an X and Y coordinate. Here's an example of a private key in hexadecimal form. The private key is 32 bytes long. Here's an example of a public key, the X coordinate, which is 32 bytes long. And here's an example of a public key Y coordinate, which is also 32 bytes long. There are two methods of using the private key to generate two different public keys, and thus two different public addresses. One method will generate the compressed public key, 33 bytes, and the other an uncompressed public key, 65 bytes, this one. The word compressed in compressed public key refers to the key length, which is 33 bytes long. The word compressed in uncompressed public key refers to the key length, which is 65 bytes long. The words compressed and uncompressed only refers to their corresponding public key sizes. In the following slide, I will show you an example of an uncompressed public key. According to this drawing, an uncompressed public key consists of a byte, the X coordinate of the public key, and the Y coordinate of the public key. For Bitcoin uncompressed public keys, the X and Y values, both 32 bytes long, are concatenated together and then prepended with a single hex value 4 byte. Here's an example of a public key X value. Here is an example of a public key Y value. Here's an example of an uncompressed public key. Here is the single hex value 4 byte, followed by the public key X value, then followed by the public key Y value. The uncompressed public key size is in total 65 bytes. In the following slide, I will show you an example of a compressed public key. According to this drawing, the compressed public key consists of the X value prepended by a single byte with the value 2 or 3. For Bitcoin compressed public keys, a single hex value 2 or a single hex value 3 byte is prepended on the X values. Which of these two single bytes is used depends on the Y value. Prepend hex value 2 if the Y value is even, and hex value 3 if the Y value is odd. Here is an example of a public key X value. Here is an example of a public key Y value. And here is an example of a compressed public key. In this example, the Y value is odd. That is why the hex value 3 is prepended to the X value. The compressed public key size is in total 33 bytes. In the following slide, I will show you an example of a compressed public address and an uncompressed public address. According to this drawing, the compressed public key is used to create the compressed public address, and the uncompressed public key is used to create the uncompressed public address. Bitcoin uncompressed and compressed public keys result in different addresses, but they still come from the same private key. Here's an example of an uncompressed public key. In the previous slide, I have shown you how this is created. Here's an example of an uncompressed public address. This uncompressed public key is used to create this uncompressed public address. In the next video, I will show you all the steps which are needed to create the uncompressed public address. Here is an example of a compressed public key. In a previous slide, I have shown you how this compressed public key is created. Here's an example of a compressed public address. The compressed public key is used to create this compressed public address. In the next video, I will show you all the steps which are needed to create this compressed public address. You can clearly see that the uncompressed public address is much smaller than the uncompressed public key. The same applies to the compressed public address, which is also much smaller than the compressed public key. The public addresses are created to make them easier to handle by humans. In the following slide, I will show you an example of a wallet input format compressed private address and a wallet input format uncompressed private address. According to this drawing, both private addresses are created using the private key. A Bitcoin compressed private address begins with the character L or K, and the Bitcoin uncompressed private address starts with the character 5. Usually, a private key in wallet input format has a different prefix to tell the wallet whether it should handle the key as one for a compressed or an uncompressed address. Here is an example of a private key. Here is an example of an uncompressed private address. And here's an example of a compressed private address. Bitcoin uncompressed private addresses begins with the character 5, as you can see over here. And compressed private addresses begins with the letter L or K, as you can see over here. In the next video, I will show you all the steps which are needed to create an uncompressed private address or a compressed private address using the private key. You can clearly see that the uncompressed private address and the compressed private address is smaller than the private key. These private addresses are created to make them easier to handle by humans. If the compressed public address is needed, the private key starts with K or L. If the uncompressed public address is needed, the private key starts with 5. Bitcoin clients can only receive coins on compressed addresses if they support compressed public keys in the first place. The advantage of using compressed public keys is smaller transactions on the network and smaller blockchain sizes. A compressed public key has only 33 bytes instead of 65 bytes. The standard Bitcoin client version 0.6 has introduced compressed keys.